Okay, I think we've about leveled out with our participants coming in. So I am Dr. Alex Feldman. I'm a neuropathology fellow at Northwestern University. I'd like to welcome everyone to the Digital Pathology Webinar series. Today's topic is going to be selecting the best slide scanner for your group. This will be organized as a 30-minute presentation followed by a 30-minute panel question and answer. I would like to say a disclaimer first. This presentation is developed with the intent to be a transparent resource for persons interested in setting up a slide scanner system geared towards those with ADRCs without certifying one vendor, brand, and/or institution above another. By no means is this comprehensive, as certain models of slide scanners, non-proprietary software, and server options, file storage options may not have been listed. We recognize that our scope of view is limited in the marketplace environment, and therefore we are dependent on our collaborators and others to provide information on additional resources. So with that said, I would like to introduce Dr. Margaret Flanagan. She's the Assistant Professor of Pathology and the ADRC Neuropathology Core Leader at Northwestern University, and she will be giving our presentation.
Thank you very much, Alex. I will share my screen. All right. So today I'll be talking about just overall how to go about selecting the best slide scanner for your group. As Alex Feldman already said, this is just a disclaimer that this presentation just expresses my opinions. I'm not representing any of the Northwestern entities, NACC, or any other individuals in any way. This is not meant to be a promotion, and again, just intended to be a transparent resource for others that are interested in setting up a slide scanner. It's not comprehensive, and I'm just going to be discussing my experiences. So digital pathology, as probably most participants in this webinar are already aware, this is an exciting technology that generates data from specimen scanned slides to generate whole slide images, and it enables digitized slide data to be transferred quickly and efficiently across distances, promoting advancements in research and education, as well as advancements in computational analyses such as artificial intelligence and machine learning, which specifically enable us to perform deeper phenotyping of neuropathology specimens. So I found this nice figure here that has 7 steps to digital pathology from the LICA website. And I just think it's a nice way to think about steps to implementation of digital pathology. So the purple stars here are what I will be focusing on today in this talk. So becoming a champion for digital pathology, defining needs and goals of your group, specifying the infrastructure and LIS needs, and building your workflow, with the second half of this being covered in later webinar sessions. So first, you need to assess the functional compatibility of each specific slide scanner for your existing infrastructure. So for example, is this going to be an instrument that is only utilized by a few users, or is this going to be a shared instrument such as that in a core facility where it's fee for service, and in that setting you may specifically be interested in choosing a system that has high throughput to facilitate the volume of use. Another consideration is, will you be using the slide scanner for Brightfield, or are you also considering using it for immunofluorescence? And I'll elaborate on these things in the next few slides. Another thing is resolution. So what sort of resolution are you going to need for your work? Are you primarily going to be scanning in slides on lower magnification, or are you interested in things for your research that may require increased resolution? So this will specifically change the specific objectives and camera for your setup. Automatic sample and barcode detection features are included in certain platforms, which are important to consider as things up front to decide on that will be helpful further down the road as you set up your workflow and infrastructure. And then what is the file format compatibility for the files that are scanned in, and what are they directly exported as? Is this going to be compatible with your downstream analysis software? So Brightfield versus immunofluorescence. So Brightfield slide scanners are capable of scanning H&E, hematoxylin, and eosin, or immunohistochemical stained slides. Scanners tend to range from about 1 to 4 minutes per Brightfield scan of a standard slide microscope slide. So this is 26 by 77 millimeters. And the timing is determined based on the tissue area that is scanned and the objective that you are using. So for example, a 20x scanned in slide will be faster than 40x. Immunofluorescence is an optional feature that you can include for certain slide scanner models. And for immunofluorescence scan speed time, you also need to take into consideration the number of channels that will be used in addition to the exposure time, as these things will also impact the overall scan time. Typically, immunofluorescence slides take longer to scan, and the file sizes are much larger than your traditional Brightfield whole slide images. If immunofluorescence imaging is something that's important to your research, as it is for mine, it's a little bit more complicated to determine which model to go with, as you need to consider more options, such as the number of channels, specific filters, perhaps other objectives that need to be added on to your base package when purchasing the scanner. And then lastly for this, are the analysis software packages that you plan to be using compatible with Brightfield and or immunofluorescence? Certain packages are specific for one or the other, for example, whereas others may be compatible with both by performing an extra deconvolution step. So important to look into these details. Some other overall considerations are throughput capacity. And so your throughput capacity of the slide scanner is determined by two things: load capacity and image acquisition time. So the load capacity refers to how many total slides can be loaded and continuously run at a time, whereas the image acquisition time refers to the time to acquire the whole slide image for your specific needs. As I explained, varies based on area, objective used for IF, number of channels, etc. And again, the throughput capacity and your individual requirements will be determined by your group's needs. And as I mentioned before, is it just one or two researchers who are going to be using this, or is it going to be an entire department, for example, or a core facility instrument? So then moving on to your space requirements, you want to determine a good place to locate the scanner, confirm that the space that you are given for the scanner has an adequate power source. In certain instances, if it's not already available, an uninterruptible power supply may need to be installed. You need to make sure that the airflow, ventilation, and temperature control is adequate to house the slide scanner, and think about the additional designated space that may be required for computer workstations, both the computer setup that goes with the actual slide scanner for data acquisition, in addition to perhaps an analysis workstation where you have comprehensive analysis software installed. Then you need to think about your group specific sample type considerations. So for example, does your group just use regular microscope slides that are 4 to 6 microns in thickness, or does your group also use thicker sections up to maybe 50 microns for stereology type of work? And if you are using thicker sections, then you want to be sure to confirm with each individual manufacturer, as it varies, that the particular system that you are considering indeed does have Z-stack functionality. Slide size is another variable. So, if you're using the regular standard microscope slides as shown here on the top, these are 26 by 77 millimeters, and then the glass cover thickness being 0.9 to 1.2 millimeters in depth. And the standard size loader is what comes with most systems. However, many manufacturers do offer a range of additional cassette sizes that can be added with an additional cost. So for our center specifically, we do a lot of work with larger brain slides specifically. So this was something that we did have to consider. In addition to your upfront costs, you also need to keep in mind the necessary ongoing personnel costs associated with digital pathology. So for an endeavor such as this, it's important to have designated personnel on the project to ensure that there's efficient use of the slide scanner platform, in addition to ongoing data management. So when the vendor comes to install the system, you ideally should have the designated personnel already identified so that they're able to actively participate in the training aspects of both the hardware and software necessary for your slide scanner to be fully functional. These designated primary users commit their effort to developing standard operating protocols for slide scanning, carrying out other operations associated with digital pathology. So in addition to slide loading, scanning, and setting up the software parameters for each individual whole slide image project that's being scanned in, they also can assist with exporting and managing the data. It's a good idea to also get IT involved to get their take on advice specifically is very helpful for determining optimal network connectivity for data input and output from the server. They can also assist and provide guidance for how you are going to store your files long-term and share them, as well as assist with any necessary security that needs to be taken into consideration longer term. So I've estimated that it's probably a good idea, but again, highly variable between centers and depending on your volume, to consider somewhere around 20 to 100% effort of a staff member to be a designated personnel for digital pathology. And this is a fairly wide range depending on the individual's level, et cetera, but approximately for that effort range, somewhere along the lines of $13,000 to $66,000 a year for this ongoing personnel cost. So load capacity, as I was talking about a little bit before, as in the definition being how many slides can you load continuously in a run at a time. And there are many different affordable smaller scale slide scanners that you are able to load 1 to 6 slides per run. However, longer term, it can become pretty time consuming for staff to load and unload slides if they're working with a large number of slides, particularly in an ADRC setting. Therefore, you may want to consider a higher capacity loader for your slide scanner. And these higher capacity loaders are usually 100 or more slides per scan. And of course, it does come with a higher upfront cost. So for example, there's a 210 slide loader that costs an additional $45,000 to purchase upfront. However, this does give you the ability to load slides far less frequently, and then the machine can continuously run the slide scans until it's complete. And this is quite efficient and potentially may help offset costs associated with personnel in the long term. So this is just a picture of just an example of one of these high throughput slide loader options, this one being 210 slides specifically, so you can see you can load these trays and walk away and have it continuously run. It's $45,000 approximately. However, just comparing this to the estimated personnel costs per year, if an individual is spending, say 30% less of their time loading slides, this could actually be a help financially over the long term. Oops. So moving on to necessary ongoing support. So there are two different things to consider for this category. One being the service contract and support options for your slide scanner itself, and then the other being your analysis software support packages and licenses if you are going for one of the non-open source options. So the slide scanner service contract details are highly variable between manufacturers in my experience, so it's important to discuss the options with each individual company in order to confirm the details. For most, however, a one-year warranty is typically included. From there, there are a variety of approaches. One being you can purchase an additional service contract, which is typically about 10% of the upfront instrument costs, so $8,000 to $20,000 per year. However, it may be possible to purchase a number of years upfront at the time of initial purchase, potentially even with a discount. Other slide scanner manufacturers support repairs free of cost, and another subset include the estimated cost of future repairs in the initial scanner price. For software support packages and licenses, I personally think that this can vary depending on an individual's needs. So for example, for myself, I didn't have a lot of experience using this type of software package. So I wanted to be sure to choose one that would be able to provide my group and I with opportunities for one-on-one teaching sessions, troubleshooting help, and then ongoing support whenever something goes wrong, if they need to install a fix for something or upgrade our software. This is all included with the license and support package, and this is about $7,500 per year. So now that I've kind of gone through all of those things and it's been a lot of numbers, I just wanted to bring up funding strategies for digital pathology. So there are a number of funding strategies that you can consider when trying to strategize as to how to fund your slide scanner. And I have just included here table 1 from the FAQ slide scanner document put together by Dr. Duggar. And as you can see here, it just breaks down. This is an ADRC Neuropath core survey initiated by Dr. Duggar. And we found here that about 50% of individuals had institutional support to help cover the costs of their purchase, in addition to a number of other methods. So grants are an option, as well as administrative supplements to existing grants. You can also consider a specific S10 instrument grant, which institutions often use to apply for instrumentation for core facilities. Department funds, such as those for recruitment or philanthropy, may be sources. And lastly, collaborative purchases with others can help offset the costs. So it may be helpful to reach out to other departments or centers, such as neurology or pathology, or perhaps the cancer center, to see if you may be able to split the cost of a scanner with them. And an additional tip is, even if others reach out to at your institution ultimately decide they may want to purchase their own slide scanner, at times, if multiple slide scanners are purchased from an institution simultaneously, companies may be able to offer an additional discount. So file format analysis, software compatibility. So Unfortunately, for us working with human samples primarily, most of the software that comes included with the slide scanner purchase is not adequate for comprehensive analyses in human neuropathology. So there are many other options which will be covered in a lot more detail at future sessions that you can consider for doing analyses on your whole slide images. They're both open source and for purchase options. And for many of the for purchase options, there are demo periods available where you're able to test the software for a determined amount of time to see if it's going to work for your needs prior to committing to the purchase. Another question to consider is, does the slide scanner you are interested in export files in a format that is compatible with your preferred analysis software? So this is important, and table 5 here from that same FAQ document from Dr. Duggar shows the different types of digital pathology slide formats that are used across ADRC neuropathology cores. So SVS is the highest, but you can see there's a range of different file types here. So if the slide scanner is not compatible right away with your preferred analysis software, there are also these additional file conversion software options to consider. So I just gave an example here to try to explain what I mean. So if the slide scanner that you're interested in purchasing exports files in a VSI file format, but your favorite analysis software that you're using specifically requires TIFF, you can add a TIFF conversion software onto your purchase, which costs approximately $1,000. And this is just a summary of the different file sizes for individual slides across ADRC neuropathology cores, which you can see here has a pretty large range, as well as the current total storage space used across ADRC neuropath cores, which about half of the people who responded were still unsure, as we're kind of still early in digital pathology. I'm sure we'll have more updated information moving forward. And then just all the way on the right for table 6, this just describes types of digital storage and sharing mechanisms that are used by ADRC neuropath cores. So the most common being on-site storage that's directly controlled by the ADC, so on-premise network attached storage. And then there's a number of other options that ADC neuropath cores are using that can include on-site storage directly controlled by an entity other than the ADC, as well as off-site storage controlled by the ADC, and cloud and centralized storage options. As far as sharing mechanisms, web portal such as eSlide Manager is the most commonly used, but other file sharing platforms such as Box or Google Drive or external hard drives are also used by some. So just a little bit on server and file sharing options. As summarized in the previous slide table, the average digital slide scan from an ADRC neuropath core ranges from about 1 to 4 gigabytes in size. And when one is scanning in multiple cases containing multiple slides, this can create a large amount of data very quickly. So it's a good idea to have a plan for how you're going to start storing it as soon as possible. At first, scanning on and saving onto a computer onto the hard drive or even an external hard drive may seem easy and lower in cost. However, you should do this with caution, as it may cause a computer to crash and may ultimately result in lost data. It's also, you can't really share data easily this way without an additional step as well. So my recommendations personally would be to have a long-term storage plan in place, such as a server that also has file sharing integration. have a dedicated method for data management and to work directly with your IT department and data core personnel as needed, as they can offer a lot of insight and guidance into these things, particularly if you have less experience, such as myself. So organizing and transferring, as I went into, it's important to organize things properly in index files. So this just outlines how to index each slide itself. So for example, you put a specimen identifier, case number, tissue region, stain, and any other relevant details. And this would be easily searchable in the future. And then just another thing that I just want to briefly mention, and it's still sort of a work in progress, is that as Alzheimer's centers are funded by the NIH and we need to report on resources shared, that with digital pathology, this will be changing in how we ask our collaborators to include acknowledgements, and we may need to do some editing with the wording whenever requests are involving whole slide images. And then this here, institutional approved HIPAA compliant method for digitized slide de-identification. This is also a work in progress with our digital pathology group, as moving forward, it's going to be very important for us to be able to be compliant and de-identify slides and whole slide digital images before sharing with third parties. So this is also something to consider up front when you're looking at slide scanner options. Is, does it have a barcode recognition feature, and how are you going to utilize that potentially both for higher throughput and more efficient slide scanning? So for example, if you can load 200 slides and have each one scanned, everything is going to be automated, decreasing personnel costs. Additionally, if you can implement that step early on with de-identification, then your samples in the neuropathology core will already be easier to share moving forward. So I just kind of want to wrap up with a working example as well as just some general tips. So basically, our group's experience, we were looking at slide scanners, and the base price for the scanner itself, which included basic slide loader, 2 objectives, camera, joystick, power supply, and delivery, about $80,000 to $85,000. But then what I worked with my collaborators to determine also needed to be added included $3,000 installation fee, $40,000 for extra necessary filters and objectives for IF and other things, a larger slide holder for stereology slides, computer and image acquisition software, image conversion software add-on, comprehensive digital pathology analyses package, as well as the 3-year maintenance, support, and license for the package, and additional computers and upgrades for computers that were utilized specifically for our workstation, which also included monitors. So about $207,000, and then we also plan to purchase a higher throughput slide loader at a later date, which will probably be about $45,000, bringing the new initial total upfront costs to $252,000. So it's a lot of money, and I just wanted to kind of share our experience and show that it is possible. It was definitely a collaborative effort, and we were able to cover these costs by a combination of grant-based funding sources. So by subsuming some of my Neuropath core effort into an existing grant, using funds from 2 other NIH grants, as I mentioned, collaborative effort with Dr. Tamar Geffen from the clinical core at the Northwestern Alzheimer's Center. We utilized carry forward funds from the P30 from our Alzheimer's Center. And lastly, we were able to benefit from a discount by purchasing our system simultaneously with one of our collaborators in the neurology department. So just some general advice: explore all of your options and make sure to ask relevant questions and confirm 100% any necessary details. So, ask very detailed questions such as, what is the exact resolution in nanometers per pixel? What kind of camera is it? The brand? The speed for actual specific scans at specific magnifications. So, not just, oh, we can scan a slide in 1 minute, but how long would it take to scan a 20x hippocampal section from a human brain with H&E stain versus the same hippocampal section of human brain using 3IF channels at 40x? It's going to be drastically different. Confirm warranty details, file type details, delivery timeline for the system, which with the COVID pandemic is actually a very important factor to confirm upfront. Confirm all of the included on-site training and installation details, service contract options, and any additional technical requirements that you need specifically for your research, such as camera upgrades for faster slide scanning times for IF, or larger slide holders. You can also ask companies if they're able to connect you with other users, and many will do this. And this allows you to directly communicate with current users and get their feedback about what it's like working with that specific slide scanner. Then kind of lastly, I highly recommend trying to test slide scanning systems and software options using your own samples. And I think this is best if possible. I just wanted to really get a feel for what the actual workflow was going to be like with my actual samples. A lot of the software analysis packages are specifically optimized for cancer samples versus neurodegenerative human brain samples. So I thought that this was a very helpful step for me. Some companies will actually do on-site slide scanner demos, so you just need to ask. So I was actually able to do this and had an on-site demo for 1 week where 2 reps came out and worked with my group, and we were able to actually test out scans on our actual samples, both Brightfield and Immunofluorescence, see what other objectives we wanted to add, and just we were able to confirm that everything would work for sure. Not all companies offer this, so you can also check out platforms that are at your institution in imaging cores. So we were able to look at the Nikon options through the Northwestern Nikon Imaging Core. It was fee for service, but you still get that firsthand experience testing your own samples. You can also reach out to other researchers and see if they might let you try their existing slide platforms. And as a last resort, companies pretty much, I think all will at least at a minimum agree to let you ship them your samples, and they will run them and scan them for you to be able to check the quality, etc. Take advantage of demo periods to test out softwares prior to committing. You may even find opportunities to collaborate with companies and create specific modules to test on your samples at no cost. And how did you like interacting with the service representative and sales representative for the company? Just keep in mind, it's a long-term working relationship. You're going to be reaching out to these people every time you need a repair, need help with troubleshooting, etc. So are they easily reachable and responsive? Do you actually enjoy interacting with them? And just to end things, there are some additional resources for digital pathology listed here. Digital Pathology Association, College of American Pathologists, Digital Pathology Topic Center, and the NACC FAQ document from Dr. Duggar. And I just want to announce our next session will be June 14th, 11 to 12 p.m. Eastern, Halo Software Overview for Neuropathology with Janelle and Dirk from the University of Washington. So thank you. Now I think we can move on to the question and answer session. And yeah, this is just when our system got delivered and how excited everybody in the lab was.
Well, thank you very much, Dr. Flanagan. I'd like to introduce our panelists, Dr. Brittany Duggar, who is the Assistant Professor in Residence of Pathology and Laboratory Medicine and the ADRC Neuropathology Core Co-Leader at the University of California, Davis. Thank you for attending, Dr. Duggar. Dr. Melissa Murray, who's Associate Professor of Neuroscience and the ADRC Neuropathology Core Co-Leader at Mayo Clinic. And Dr. Alessandra Martini, Associate Project Scientist at University of California, Irvine. Thank you all for attending. We had a couple of questions that I saw, so let me ask these. One from SIAC is, are there any open source whole slide imaging viewing software for downloading whole slide images, or the files can be viewed by proprietary software only? Would anyone like to answer that question?
I put a comment in the chat, so thank you for that great question. One of the ones that we are going to be highlighting in the webinar series, and Dr. Flanagan can probably give that date, is QPath. So that is open source, and I even included in the link, there is a paper that was written on that. But there are a couple others if the other panelists would like to chime in about open source, freely available softwares that could help.
I'm not as familiar with them, but QPath I think is really one that a lot of individuals use, and people use ImageJ. But I'll add in a quick search I found. There's a whole wide range of open source options. I'll include it in the chat as well.
Mm-hmm. With that though, just so everybody's aware, when things are scanned in, they're scanned in pyramidal TIFF files typically, so they'll have multiple layers. So say like if you're going to be opening something and say just Melissa or Dr. Murray mentioned ImageJ, a lot of times you're going to have to choose one of those layers to open things up. And sometimes you're trying to open it up a computer that might not have computational power, and that could affect things. So just to be aware of that, it's not just going to be opening up the file. You kind of have to choose which one. I don't know if anyone else wants to chime in on that.
That's a good point. And part of the difficulty is these are such huge files, and it's not necessarily, the file types aren't necessarily proprietary, but the file types that are specialized are just this massive compression capability that enables you to deal with them.
Yeah, we've been using Qpad with also the purchased software package, and we're having a good experience with that. I think because of these issues, the files are just massive. So it's something to definitely take into account when choosing an analysis package.
Okay. Another question that I see is, how does everyone utilize scan sites currently? And did you have to justify the cost or have to estimate cost savings or increase productivity?
So how does everyone use the scan slides currently? For almost every single thing that I do. Digital pathology is really useful when comparing it to an antemortem clinical measure. It really helps to provide that functional aspect in the postmortem brain. And so that could be neuroimaging changes. That could also be changes in cognition that you are investigating a specific structure and wanting to understand. It could be age and sex differences where you can really separate out. I mean, I'd love to hear from others how they're engaging with the digital pathology. Or even the other one was, how did we pay for it? What I was trying to find which question.
Yeah, justify the cost.
And so Dr. Flanagan, you did a great job really summarizing some of the really important aspects that you have to think about with regard to the costs. But they put your studies on a whole other level. It really provides such a depth of information that you can parse out, especially when you get interested in almost minute details that might take you 1,000 years to count. So if you find yourself sitting at a microscope doing a lot of counting, this is some of the aspects that you want to look forward to. And so I've integrated it into my grants, and in fact with my personnel, and with regard to the budget justification, you'll want to think ahead, like Dr. Flanagan pointed out, what will be involved. And it's really becoming quite well received at study section. People recognize the importance. And so as long as you're thinking carefully about it with regard to your studies, the justification almost writes itself.
Well, and to add to that, Dr. Murray, and maybe just to speak a little bit of like institutional jargon, if you're asking for institutional support, it's always good to have some sort of a white paper that has like a return on investment. Because if you're asking the university to support, maybe help with the service contract or personnel, be like, hey, this is what this can provide. And some of the arguments that I've used is it's not just from the deeper phenotyping that Dr. Murray mentioned, which is great, right? Because we have such finite scales, none, mild, moderate, severe, which might not capture differences that are happening in the brain. But there's also things of the educational and consultation purposes. And so you think of, if you have a medical school, potentially how could you utilize the slide scanner to help with medical education? But that gets into a whole bunch of different ballgames. But just think of, again, the plethora of resources that you have around and adding that slide scanner, how could that integrate into things? And so that's always helpful, especially when you're approaching the higher ups and getting stakeholders too. Like Dr. Flanagan mentioned, and how another institute or somebody else in the department was purchasing another slide scanner. And one thing just to mention, it's a little bit tangential, but this is especially new for a lot of the newer investigators, is you can get a new investigator discount, and it can be pretty substantial when you're purchasing things. So always think about that, especially from a recruitment standpoint. If there's somebody new coming on board in your department that might classify in that status, like, could you utilize that route?
Okay, I've seen another question. Is there any scanner that you can change the objective color for better scanning quality?
With Aperio, I mean, Dr. Flanagan, you want to speak to it from your perspective, but we can, using Aperio technology, you can do a pseudo doubler. So we scan at 20x, but you can scan into 40x. And I think the newer version, the GT 450 model, supposedly it's not a pseudo doubler. I haven't worked with it yet, but there are, and I think there's quite a range with the fluorescence scanners that you probably came across during your.
Yeah, so I can comment on this. So I know I've tried that out and it works for some things better than others. And I just would recommend, if you can, just test your samples to see how it's going to work. Because, for example, I thought, oh, this type of technology could be great and really speed up scan times. And just depending on what marker you're looking at, it works or it doesn't. Sometimes it just doesn't quite give you the same resolution as, better objective, but sometimes it does. So yeah, I just wanted to reemphasize trying to just see what your own samples look like for that particular manufacturer and option. And you can, at least for most of them, including Olympus, you can add extra objectives. It comes with 2 up front, but there's a wide range, and it's kind of customizable depending on what your needs are. Swap things in and out.
The one thing to keep in mind with objectives and going into higher, you have to keep in mind the time commitment, because as you double that, really you're going to be doubling your scan time. And so you just may want to consider, what is the important aspect of your field of view. We have a P250 flash that we use for fluorescent scanning, and it gives beautiful images that we're able to utilize, but we have to think critically of what is the area of interest that most is, and that's exactly what you touched upon. What are your needs? Make sure you scan those needs early so you can find out.
Okay, another question from John. Are there any cloud-based options for looking at images?
I know so we're currently using Halo, and I know that there's a web-based viewing option through the Halo link specifically that I believe will be covered in more detail at the next session by Dirk and Janelle. I have to say I have not tried it personally yet. but that's definitely one option. I don't know if anybody else has any others to add.
I just put in the chat, it's another paper, just because, you know, being a scientist, you always want to have more papers on your desk. So it's an example of a web-based software. This is the Digital Slide Archive. This was put together by Emory, mainly for cancer. So that's another great resource that we have, is cancer is so malignant in so many different ways. They've also been very malignant also in the digital archive. So they've laid the path a little bit for the neuroscience community as well. So hopefully that helps with that. But and with the Halo that Dr. Flanagan mentioned, that can be quite expensive as well. So I'm trying to remember some of the cost points for Halo and whatnot. So this is a huge issue right now. So whoever asked that question, it's so poignant, because that's what we're trying to deal with. Because as you know, even with storing any data or sharing any data, this is an issue. There's genomic data, this and that, and how you're doing that can be quite different. So it's a very poignant question. And there are a lot of companies out there. So you mentioned Halo, Proscia is another one. I believe they're the ones that just partnered with the Armed Forces Institute. And they're scanning in that huge archive, working with the Department of Defense. So there's that huge thing, but they're also linking that with clinical data as well. So you always have this kind of concept, just like Dr. Flanagan mentioned, how are these softwares integrating with other back-end, front-end aspects. Dr. Martini, did you have anything to add? What did you see I use?
So we've been using only Slide Manager to view the images, and depending on the collaboration that we have, we just provide the original files so the person can use on the software that they prefer. But that's the only thing that we've been using now. And we used also Globus, right, Brittany? That it's one of the cloud-based options that you can, but it's more for sharing.
Yeah, it's more for sharing. So Globus is out of University of Chicago, Illinois, and it's not a slide sharing software. We're just using it like that.
It's more just the cloud storage, not for viewing the images.
Yeah, it's really hard because we tend to sling, you know, let's break that up. That's a really good point, Dr. Martini, is you have the whole viewing aspect, right? But then you also have the file sharing aspect. And so a lot of us have just focused on file sharing. Like I myself have just used Google Drive because it's easy to do. A lot of people have it, and then we sling the files, but then viewing the stuff can be a totally different ballgame. I don't know if that helps or complicates things, but that's our status right now. And in the chat, I'm putting the link to the Proscia announcement with the joint pathology centers too. So I just put that in the chat as a link.
And the question came from John Chow, who has been a really strong proponent for a lot of the research that's being backed by NIA. And just so that everybody on the call or on the Zoom is aware, one of the major reasons that we're here today and this digital pathology work group formed is to be able to try to identify a mechanism that we can, across centers, share slides and visualize them. And it's been challenging. And so that part of the goal is to have these webinars to share the information, and then that way we're being successful while we're struggling to figure out the other aspect. And so we definitely look forward to updating the community and trying to really figure out a way to move forward with this. Let's see. Are there any other questions? Wow, I guess go ahead.
Any?
Sorry.
Submit more questions if you have any. I'll ask a question. How and where do you guys store your digitized slide files?
I'm so happy for y'all. So we have a wonderful IT department. Our cancer research building and researchers had really developed an interest in digital pathology very early, about 2006. So we started in the game in about 2007, 2008, and it's grown. So we started with just, you know, a terabyte of space that has just grown in multitudes. So we have physical servers, but we'll be moving ours to the cloud. What do y'all do at Northwestern?
Server right now, yeah, to get set up. We have also a great IT setup and, you know, unlimited space, and it's all secure and everything. So that's our first step. But similarly, we are looking to eventually transition to a cloud and something where we can share more easily with others at outside institutions.
Yeah, I think we're all in the same situation. We also have a server, and we recently increased because the start space that we had just wasn't enough. And we're looking to cloud options, or at least to store the older files, and then we can keep the ones that we're working on. But for sure, it's something that you definitely need a great IT team. And we're very fortunate to have one.
That's also something to work in the budget too. So we went the administrative supplement route, and we got the scanner, and we budgeted about 30 grand. And with that, we got a 5 RAID 50 terabyte system for on-prem storage. And why we did that is it can be proximal to the slide scanner. We are very blessed to kind of have that arrangement so the files can be transferred faster. And even with that too, to kind of highlight maybe some of the upcoming webinars that we're going to be doing with this digital pathology series, is we allocated some funds for GPUs as well. So we bought a GPU to kind of be parallel right there, so then you could pull the data right from there and not have to deal with upload speeds or download speeds when you're trying to run crazy analysis on stuff. And we made it on a portable rack too. That was the other thing with talking, just like, hey, talk with IT, and they're really good with helping with switches and all that stuff. So start your conversation with IT early on that kind of stuff. And then Dr. Martini, I really like how you stated about there's long-term storage and then there's short-term. So that's another thing to think about is, in the long term, a lot of time people will term it glacial, like where's your glacial storage versus immediate storage, and trying to have a plan for that is really.
Yeah, that is definitely something very important that we don't think up front, I think, because you won't be working with all those slides all the time. So you scanned all of them, you used, and you want to keep the images, but you have new slides coming in. So what do you want to do with the old ones that you're not working on right now? So it's something to think about, how to better store all your images.
And especially if you're pairing it with an auto stainer where you're controlling for the experimental design of staining. Granted, there's fluctuations and everything, but the beauty of digital pathology is tissue is not infinite. You know, we have to be very cautious about how we utilize this precious resource. And so similar slides from different studies can then be used again. So you're actually really exponentiating. So one of the things that I really was glad that you pointed out earlier, Dr. Flanagan, was think about the databasing aspect. You want to make sure whatever digital pathology route you take, you can create a nice database so you can easily look up your identifier, the stain of interest, so that if Dr. Martini then submits hers for storage to be brought back up, she can easily recall the case. And so it really is helpful for that integration.
I just wanted to ask you, as the other panelists, have you gone live at all, even internally, with research requests for whole slide images? Or yeah, how's that been going? Or did you want to comment on that?
We went live because just there's a lot of stuff going on with mainly my collaborators, right? I've been very blessed to have amazing computer engineering collaborators. I myself, you know, even though I'm talking to you about like 5 RAID system, I'm just regurgitating what the engineers told me. I just thought RAID was something that killed cockroaches, but apparently it's something else too. So with this, yes, we've gotten a lot of requests and we're actually tracking them because you mentioned very nicely, Dr. Flanagan, we're funded by the NIA and we need to keep track of all the resources that we share, even though it might not be funded right now, right? Because a lot of our costs are focused on brain procurement and diagnosis. But that's a conversation that, you know, having with the higher ups, like Nina, Dr. Silverberg has been such a great supporter of this. I don't know if she's on, but thank you, Dr. Silverberg, for this. And just understanding where do we go from here? We've been driving a horse and buggy. And when do we move to an electric car? You know, just trying to think of that. So yeah, we've been sharing it and we've updated our data use agreement. So we're treating whole slide images as data. That alone was a conversation with our material transfers office because they were thinking that it was like physical slides and we're saying that it's digital slides. So it's trying to get everybody on the same page with jargon and where do these things fall. Other things that we've done is we've pushed to an online collaborative agreement form too, which is helpful because now you're sending files. And think about it, somebody goes, oh, I have this file, I'll easily send you this H&E of the hippocampus, but technically that could be considered third-party sharing. So you have to make people aware of that, even though it is just a digital material, just that whole kind of workflow. Is that helpful, Dr. Martini? Did you have anything to add, Dr. Murray?
Yeah, I don't have anything else to add because you were very on point. But again, I think it's just a matter of we need to start thinking about it's digital, but it's still a slide. So you cannot just easily share without any restrictions. Dr. Murray, do you have anything else?
It's a good question. It's because we're stuck in this rock and a hard place. So there's multi-site consortia efforts where they have exchanged hard drives in order to be able to share the whole slide images. And it's worked well, especially while we're trying to understand. And it goes back to the cloud-based question that we really need. And we'll have to really figure out a good way to do this. But there are other considerations too, the protected health information. So making sure that you have your slides stripped. We're fortunate a member of our team has figured out how to code it. And he's a neuropathologist. It's fascinating. But so there are different aspects to the importance of it, but we are in that era where we will be. It's just kind of hard right now while we figure out the infrastructure.
Yeah, thank you both for your comments. I'm like just kind of progressing up to this point, and yeah, it's complicated.
Well, I think that is all the questions that I have seen. If any of our panelists have any questions for any other panelists, or we are basically at the 11 o'clock, just about finished. Any other questions?
No, I think it's been a productive morning. I think this has been a great conversation, really helpful questions. Great job emceeing.
Well, thank you very much. Well, I'd just like to thank Dr.
for stopping by. Like this was awesome to see so many attendees and so many great questions. So thank you all.
Yeah, and I just wanted to end things by reminding everyone about our next session, which will be, again, June 14th, 11 to 12 Eastern Time, focusing on Halo software overview for neuropathology research, led by Janelle and Dirk, Dr. C. Dirk Keene from the University of Washington. So thank you, everyone, and hope to see you next time.